Good morning all, my name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about question bank discussion on spatial domain filtering. So first question is, classify the types of filters in spatial domain filters of image enhancement. So first what we have to do means, here the types of filters, how many types of filters are there. After that it is in spatial domain. So actually filters are in the two types, spatial domain and the frequency domain. But they are asking the types of filters in, especially in spatial domain of image enhancement. So first we have to do is, what is image enhancement? First question is, what is image enhancement? After then, classification of filters in spatial domain. We have to discuss this one. So first one is a spatial filtering. Spatial filtering is a technique is used directly on pixels of an image. Mask is usually considered to be added in size so that it has specific center pixel. This mask is removed on the image such that the center of the mask transverses all the image pixels. So spatial filter. So first one is a spatial filter. Any of the filter, we need a mask. Mask is using to remove the noise. So spatial filter technique is used directly on pixels of an image. Mask is usually considered to be added in size so that it has specific center pixel. The mask is moved on the image such that the center of the mask transverses all the pixels. So what are the classifications of the linearity of the function? So there are two types of spatial filters are there. Linear spatial filter, non-linear spatial filter. Okay. So spatial filters are two types, linear, non-linear. But frequency domain, but not in the spatial domain. In the frequency domain, only linear is there. There is no non-linear. So linear frequency domain filter. There is no non-linear is there. But in the spatial domain only, we have two types, linear and non-linear. But in the frequency domain, only linear is there. So these are the classifications are there: linear spatial filter, non-linear spatial filter. So filters in spatial domain. What is the need of filters in spatial domain? Spatial filters are used different masks. There is a one-to-one correspondence between linear spatial filter and filters in frequency domains. Spatial filters can be used for linear and non-linear filtering. That is a frequency domain just for non-linear filtering. So the mechanics of spatial filtering consist of neighborhood, that is a small rectangle, predefined operation that is performed on the image pixel. Filtering creates new pixel with coordinates equal to the coordinates of the center of the neighborhood and whose value is the result of the filtering operation. So here I am talking about filters in the spatial domain. Okay, maybe that is a linear or non-linear, what it may be. We have to discuss common spatial domain filterings. These are the different masks. Any of the filter, we need a mask is a major role, and there is a one-to-one correspondence between linear spatial filter and filter in frequency domain. The spatial filters can be used for linear and non-linear filtering. That is a frequency domain just for linear. Already we discussed frequency domain is a only linear, but spatial domain is a linear and non-linear also there. In the spatial, linear and non-linear are there. So it is only two types, it is only one type. The mechanics of spatial filtering. It consists of neighborhood, predefined operation. Filter creates the new pixel and the coordinates of the center of the neighborhood and whose values are the result of the filtering operation. So another question is, describe various types of mean filters for image enhancement. Describe various types of mean filters for image enhancement. In the image enhancement process, we are using so many types of filters are there. But here they are asking what is the mean filter and what are the types of mean filter. Types of mean filter. So first we have to discuss what is mean filter. After then we can go for the types of mean filters, which is related to the image enhancement. So mean filter is a linear spatial filter, is simply the average of the pixel constrained in the neighborhood of the filter mask. The idea is replacing the value of every pixel in an image by the average of the gray levels in the neighborhood defined by the filter mask and multiplied by a higher value than average filter. Okay, so mean filter is a linear. Actually, we discussed there are two types of filters, linear, non-linear. But here, linear spatial filter is simply the average pixel content of the neighborhood of the filter mask. So mean filter is nothing but a linear spatial filter. The idea is replacing the value of every pixel in an image by the average of the gray levels in the neighborhood defined by the filter mask multiplied by a higher value than average filter. Types of mean filters: averaging filter, weighted averaging filter. First one is, these are under mean filters. So first one is a averaging filter. It is used in reduction of the detail in image of all coefficients are equal. Second one is a weighted average filter. In this pixel are multiplied by different coefficients. Center pixel is multiplied by a higher value than the average value. So average filter is one type. Weighted average. So in the average filter used for reduction of the detail in image, all coefficients are equal. Weighted average filter in these pixels are multiplied by the different coefficients. Center pixel is multiplied by a higher value than the average filter. So another one is an order statistic filter. It is based on the ordering the pixels contained in the image area encompassed by the filter. It is replaces the value of the center pixel with the value determined by the ranking result. Edges are better preserved in this filtering. Okay, what are the edges are there? We have to better preserving of the system. So order statistics is the based on ordering the pixels contained in the image area encompassed by the filter. It replaces the value of the center pixel with the value determined by the ranking result. Edges are better preserved in this filter. So types of order statistic filter. Already we just now discussed order statistic. Here what are the types of order statistic? First one is a minimum filter, another one is a maximum filter. Minimum filter is nothing but a 0th percentile filter is the minimum filter, and the value of the center is replaced by the smallest value in the window. Okay, so 0th percentile is the minimum. What is the maximum in 100th percentile is the maximum. So 0th percentile filter is the minimum filter. The value of the center is the replaced by the smallest value in the window. Maximum filter is nothing but a 100th percentile filter is the maximum filter, and the value of the center is replaced by the largest value. Why? Because it is 100th pixel, largest value in the window. It is a smallest value in the window. Why? Because it is a 0th percentile. Another one is a median filter. Minimum filter, maximum filter, median filter. Each pixel in the image is considered. First, neighboring pixels are sorted and original values of the pixels are replaced by the median of the list. Sharpening spatial filter. It is also known as derivative filter. The purpose of the sharpening spatial filter is just for the opposite to the smoothing spatial filter. The main focus is on the removal of blurring and highlighting the edges. It is based on the first and second order derivative. Okay, remove blurrings. So which type is better means spatial. In the spatial, which one is better means sharpening. Sharpening is for removing the blurring. Smoothing is nothing but a reducing the noises. So in the spatial filter, two types are there. Smoothing and the second one is a sharpening. So in the smoothing, removing the noise. In the sharpening, we are removing the blurrings. It is also known as derivative filter. The purpose of the sharpening spatial filter is just for the opposite of the smoothing. The main focus of the removal of blurring and highlighting the edges, and the based on the first order and second order derivative. First order derivative must be 0 in flat segment, must be non-zero at the onset of a gray level step, must be non-zero along ramps. Okay, these are the first order derivative. Must be 0 in flat segments. Flat segment means there are normal, all segments are in the equal level. Non-zero means all segments are in non-equal. That is a gray level step. Must be non-zero along ramps. It is the first order derivative. And first order derivative I am taking as a 1D image. 1D image means only f of x will be there. 2D means f of x comma y is there. If I am taking 3D means f of x comma y comma z. 1D means f dash equal to f of x plus 1 minus f of x. Second order is must be 0 in flat areas, must be 0 at the onset and end of a ramp, must be 0 along ramp. First, what is the second order derivative for 1D? Second order is for 1D. F double dash equal to f of x plus 1 plus f of x minus 1 minus 2 into f of x. Here f dash of x equal to f of x plus 1 minus f of x. Here f double dash here asking f double dash equal to. Why? Because it is a first order. F dash equal to first order. F double dash is nothing but a second order. F of x plus 1 plus f of x minus 1 minus 2 into f of x is the second order derivative. Another question is there in the question bank. Explain in detail about histogram processing. Histogram is a main thing here. Histogram is mainly using for finding the segmentations. What are the levels of the image? Image levels, image segmentations are showing here. So histogram equalization is a computer image processing technique used to improve contrast in images. It accomplishes this by effectively spreading out the most frequent intensity values, that is stretching out the intensity range of the image. In the image processing context, the histogram of an image normally refers to a histogram of the pixel intensity values. This histogram is a graphical showing the number of pixels in an image at each different intensity value found in the image. So, in the image enhancement, it can be done by histogram equalization. Histogram equalization is a technique for adjusting image intensities to enhance the contrast. When we are changing the intensity values, then the contrast of the image will be increasing. That is the histogram equalization. And this method usually increases the global contrast of many images, especially when the usable data of the image is represented by close contrast values. Histogram modeling technique is nothing but a histogram equalization, provide a sophisticated method for modifying the dynamic range of contrast of an image by altering that image such that it is the intensity histogram has a desired shape. So intensity is changing. That is a histogram equalization. So when we are increasing the changing width, the contrast is increasing. Okay, like this. It is one example. It is a new image and it is an old image. So what is means here? There are noisy is there. How I know what it means? You can see the graph. It is a noisy. Here the noise is reduced like this. Okay. Here there is full x to here to here. The complete what is a graph you can see histogram. Here increasing, after then it is decreasing. Here after then there is nothing is there. So old image, it is a noiseless. So how I know means with the help of histogram only we will finding out. Okay. So what are the silent features of image histogram? Histogram equalization is a computer image processing technique used to improve contrast of an image. It accomplishes by effectively spreading out the most frequent intensity values, that is stretching out the intensity range of the image. So what are the features? Histogram is a computer image processing technique used to improve contrast, accomplishes effectively spreading out the most frequent intensity values, stretching out the intensity range of the image. So how histogram equation is used? What are the steps? Means first get the input image, generate the histogram for the image. I'm taking first, suppose I'm an image. So that image we have to go for the histogram. After then find the local minimum of the image. Next, divide the histogram based on the local minima. Specific gray levels for each position of the histogram. First go for the gray levels for intensity values. If intensity values are changed, then contrast will be increasing. Apply the histogram manipulation for each partition. Okay, these are the steps involved in the histogram equalization. Select the input, select the histogram and local minima, divide the histogram based on the local minima and specific gray levels of each partition of the image histogram. Apply the histogram equalization of the image partition. This histogram can be classified into different types. So what are the classifications of histogram? Uniform histogram, symmetric histogram, bimodal histogram, parabolic histogram. These are the four types of histogram equalizations are there. Okay, uniform histogram, symmetric histogram, bimodal histogram, probability histogram. What are the applications of digital image processing? So in the digital image processing, applications of histogram. So it is nothing but these are using a digital image processing. So the histogram in the the histogram is a digital image processing. The histogram is majorly using in digital image processing. So the applications of histograms are used for simple calculation in software, used to analyze an image. Properties of image can be predicted by the detailed study of the histogram. The brightness of the image can be adjusted by having the details of the histogram. So what are the first application of histogram? All those are related to the image processing. First application is used in simple calculation in software. Okay, and used for analyzing the image. Analyzing means what are the intensity values are there, then only we can find out the analyzing this one. Properties of image can be predicted by the detailed study of the histogram. Brightness of the image can be adjusted by having the details of the histogram. So but how we are increasing the brightness means we are taking the intensity values. Intensities are increasing. Explain the steps in histogram equalization. Histogram equalization is a technique for adjusting image intensities to enhance the contrast. Let f be a given image represented as a MR by MC matrix of integer pixel intensities ranging from 0 to L minus 1. Here L is the number of possible intensities. Number of intensity values from 0 to 255. Total 256. So intensity levels are from 0 to 255. 256 intensity levels. So histogram equalization is a technique for adjusting image intensities to enhance the contrast, and it is representing as in the form of matrix with in the range of 0 to L minus 1. L is nothing but the total intensities, that is a 256. The parts of histogram, x-axis, y-axis. Any of the image I'm taking, suppose I'm taking 2D, that is the x and y-axis. The intervals under which the measurement falls is shown in the x-axis interval, and the values of the occurred within the intervals set by the x-axis as shown in the y-axis. The bars are used to showing the value of the data of the image in the pixel intensities of the x-axis versus y-axis. The x-axis is available in gray levels, and the y-axis indicates the number of pixels. Y-axis is called the number of pixels. X-axis are the gray levels, y-axis are the number of pixels. So, what are the advantages and disadvantages of the histogram? A histogram cannot be used to represent discrete frequency distribution, and it can be used to represent continuous frequency distribution. And what are the disadvantages compared to a box plot is that a box plot gives us extra information such that median, upper quartile and lower quartile of the data. So histograms are major advantages are there in the digital image processing. So it cannot be used to represent a discrete frequency. Okay, we are not using discrete, only continuous frequency. Continuous frequency, not the discrete. It can be used to represent a continuous distribution. So what is the disadvantage means? Comparing the box plot, the extra information of the median, upper quartile, lower quartiles of the data is showing. Okay, and it is one example of histogram equalization. It is the input, so it is some dominating. So noise levels are there. Noise is more. So how I am showing means corresponding histogram, cumulative histogram. So how much noise levels are there? It is showing in the histogram process. Okay, it is output, that is a noiseless. So it is a some systematic order. So it is a histogram equalization at output. So input is a noisy. How noise is, how much percentage of noise is there? Here continuous red colors are there, continuous lines are there. Here there are some systematic process is there, and it is a threshold level is there. What is the threshold level also? We are finding out this one. Okay. So upon, depends upon the threshold level, we are converting, we are remove the noise. So how much percent of noise is removed means with the help of histogram process, it is showing the noise levels or visibility of the image. And what is the smoothing in spatial domain? What is smoothing in spatial filter? So smoothing filter is used for blurring and noise reduction in the image. Blurring is pre-processing steps for removal of small details, and noise reduction in accomplished by blurring. What are the types of smoothing spatial filter? Linear and order statistic filters are there. Okay. So smoothing is a major role in the reduction of noises. Okay, there are two types are there: linear, non-linear. It is a mean filters are there. Types of mean filters are there. So here the main things in the spatial filtering is that we are classifying the filters in the spatial domains or spatial filtering and the classification of the linearity. So linear spatial filter, non-linear spatial filter, two types of spatial filters are there in the image processing. In the first one is a filters in spatial domain. So spatial filters are used in different masks. There is a one-to-one correspondence between linear spatial filter and filters in frequency domain, and it can be used for linearity and non-linearity of the filters. The mechanics of spatial filters are neighborhood, predefined operation that is performed on the image pixel. It is filtering is creates a new pixel with coordinates equal to the coordinates of the center of the neighborhood and whose values of the result of the filtering operation. What are the various types of mean filters are there? So the mean filter is a linear spatial filter to contain the neighbor of the filter mask. The idea is replacing the value of every pixel in an image by the averaging of the gray levels multiplied by a higher value of the averaging filter. So types of mean filter means average filter, weighted average filter, order statistic filter. In the order statistic, minimum filter, maximum filter, median filter, and sharpening spatial filter. There are two types of spatial filters: sharpening and smoothing. Sharpening is using for the unblur, removing the blurrings. That is the sharpening. Smoothing is for the reduce the noise. So there are two types are there: first order and second order. So first order must be zero at flat segment and non-zero at gray level and non-zero at along ramps. What is the first order 1D derivative? F dash equal to f of x plus 1 minus f of x. Second order is equal to f double dash equal to f of x plus 1 plus f of x minus 1 minus 2 into f of x. And in detail about the histogram process. It is a equalization using in a computer image processing technique to improve the contrast of the image. And it is a normally we are using the histogram is the pixel intensity values. When the intensity values are increasing, then the contrast will be improved. And image is the equalization technique can be adjusting the intensities according with contrast, and it is a global contrast of many images, especially usable data of the image represented by close contrast values, and the dynamic range and contrast of the image altering the modifying the image. The intensities histogram has desired shape. Here the old image with histogram, here new image is there. Here old image is good one, but in new image is a noisy is there. We have to reduce the noises. Why? Because here dominating the white, here normally is there. Say what are the silent features of image processing is it is a computer image processing technique used to improve contrast in images and accomplishes this by effectively spreading out the most frequent intensity values, stretching out the intensities range of the image. What are the histogram equalizations are used? What are the steps are there? First, selecting the input image, generating the histogram, and finding the local minima, dividing the histogram based on the local minima, have the specific gray levels for each partitioning of the histogram, apply the histogram equalization of each partitioning. And the histogram can be classified as a four types: uniform histogram, symmetric histogram, biomodal histogram, probability histogram. So what are the applications means? Histograms are used for simple calculation in software, used to analyze an image. Properties of image can be predicted by the detailed study of the histogram, and the brightness of the image can be adjusted by having a detail of its histogram. What are the steps are there in the histogram means? Histogram equalization is a technique for adjusting image intensities to enhancing the contrast and representing with MR and MC of the matrix. The ranges are 0 to L minus 1. L is the number of intensities, that is 256. And the two axes are there, x-axis and y-axis, that is a 2D image. And advantages are that it can be used in continuous frequency distribution, but it not be in discrete frequency. What is a disadvantage is that the median upper and quarantile lower qualities of not mentioned in the images. Okay, it is one noisy image and a noiseless image with histogram equalization. And it is a smoothing spatial filter. Smoothing spatial filter is for removing of noise, removal of small detail of noise. Okay, there are linear filter, order statistic, that is a non-linear filters. So mean filter is nothing but a linear spatial filter, is simply the average of the pixel containing the neighborhood of the filter mask. The idea is replacing the value of every pixel in an image by the average of the gray levels in the neighborhood defined by the filter mask, multiplied by the higher value of the average filter. What are the types of the average filter? Weighted average, minimum filter, maximum filter. And smoothing filters are used for blurring and for noise reduction. Smoothing filters are used for blurring is removing in the small detail of bridging of small gaps in the lines. Smoothing spatial filters include linear filter and non-linear filter. So here g of x comma y equal to capital T of f of x comma y. So what is f of x comma y is the input image, g of x comma is the output image, and t is the operation of f defined by the t is a method operator or method is used in that. So the general implementation of filtering an image with weighted average filter is that g of x comma equal to summation is equal to minus a to a, t equal to minus b to b, w of s comma t into f of x plus s comma y plus t by w of s comma t. Here m equal to 2a plus 1, n equal to 2b plus 1. Here it is a sample example for 2 into 3 by 3 smoothing average filter mask. The constant multiplication of front each mask is equal to 1 divided by the sum of the values of its coefficients is required to the computer average. Okay. So here I am taking 4, 1 by 16 equal to 1 by 2 power 4. Here the 4 is the segment SC. Here SC equal to 4. Okay. So what are the two surroundings are there? Here 2 and 1s are there. 2 1s are there. Here 2 and 1s are the showing as a intensity values are there. Here 1 by 9 is a mask. Applying the mask here. It is an image size of 528 to 480 pixel with a Hubble Space Telescope. The image filter with a 15 by 15 image mask. The result of the thresholding of the image. Okay, it is the output result using mask. Okay, and non-linear based on ordering ranking of the pixel content filter mask, replacing the value of the center pixel with the value determined by the ranking result. Examples are median filter, maximum filter, minimum filters. Okay, and these are the spatial domain filters are there. So in the smoothing spatial filter, it is used for blurring the what are the blurring of the images are there, that is a blurring noises reduction. Okay, so it is a pre-processing steps for removing of small detail of noise reduction. Linear filter is nothing but a mean filter. Order statistic is nothing but a non-linear filter. So linear filter and non-linear filter, that is a mean filter, order statistic. In the previous slides we discussed what is a order statistic, what is a mean filter. Order statistics are three types: minimum, maximum levels are there. In the mean filters are there. There are the three types are there. So what is a mean filter? Types of mean filter: averaging filter, weighted averaging filter, and another is a order statistic filter. Mean filter are two types, and it is a order statistic filter. So in the order statistic, how many types are there means minimum filter, maximum filter, and median filter. So these are the three types are there. So linear filters are two types, non-linear filters are three types. So these are mean filter and order statistic filter. So it is a mean filter, that is a linear spatial filter, and the idea is replacing the value of every pixel in an image of the average of the gray levels of the neighborhood, the multiplied by the higher value than the average filter. And it is an average filter. You are taking the average of the pixels. Weighted average means average value of this one. Order statistic means highest value and lowest value with the replacing of the image, that is the encomposing of the image. It is replacing the value of the center pixel. Determine the ranking result. Edges are better preserved in the filtering. And minimum filter is not 0th filter percentile. Maximum is the 100th percentage of the filter. Smoothing filters are used for blurring and for noise reduction. Blurring is used for removal of small details of bridging of small gaps in the gaps. Smoothing spatial filters include linear filter and non-linear filters are there. Just now discussed non-linear, linear. So in the linear, two types are there. In the non-linear, three types are there. So mean filter is a linear filter. Average filter, weighted average are the types of linear. Non-linear is the order statistic. Minimum filter, maximum filter, mean filter are the non-linear filters. It is the equation of smoothing filter. G of x comma y equal to capital T of f of x comma y. F of x comma y is the input image. G of x comma y is the output image. And T is the operator of f defined over a neighborhood of point x comma y. It is a generalized implementation of filter of m into n image with a weighted average filter. And it is an example of 3x3 smoothing averaging filter, and the constant multiplication of front of each mask is equal to 1 divided by the sum of the values, and the coefficients are equal to the compute the average. Okay, it is the input image and it is a mask. So middle one is a segment, image segment is equal to 4. Why? Because 1 by 16 equal to 2 power 4. It is a 4. Okay, what are the 1 and 2 are nothing but the intensity values of black and white. That means a gray levels are there. It is one example of mask level input to output. The mask means 15 by 15 averaging mask is using. The input is a 528 into 485 pixel size of Hubble Space Telescope. And it is a non-linear based on ranking the pixels contained in filter mask. Replacing the value of the center pixel with the value determine the ranking result. Example of median filter, maximum filter, minimum filter. So these are the three types of non-linears are there. Non-linear are median, maximum, minimum. Three types of non-linear filters are there. Okay, these are the references. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.